Hello. I'm going to share you some interesting fact about this metal wire stringers. In A-level physics, there is less detailed portion, but when you do a further studies, you will find out the most interesting things in metal wire stringers. This is the uh, actual diagram of metal wire stringers, and here you see this is the length and this is cross-sectional area, and these are the 2 points. So what happened actually, the application of this metal wire stringers is in cracking area. So here you'll attach metal wire stringers, and here you'll mm, uh, connect this into indicator, and when this grade is increases, this act as a resistance. I'll show you this later. Okay, so this is the actual diagram of metal wire strain curves. You don't have to draw it. So here, when strain is applied on plastic plate, it is stretched. So I told you, so when strain is applied on plastic plate, its length increases but its cross sectional area decreases. Okay, and here length of wire increases and its cross sectional area decreases. I told you here, and here is also, when this increases this decreases, and when this increases this decreases, same thing. So here so this is the length and this is the cross sectional area. So when this length gets increases, this cross sectional area also get decreases. And here in both cases resistance increases, since there is a very small change in area, it can be neglected. So there is, so small change can be neglected. So I told you, like length is inversely proportional to area. So when this area increases, length decreases. So look at here, uh, r rho uh, r rho L by A. So what happened when this area increases, this length grade decreases. Okay, it means that when this decreases, sorry, let's talk another thing. So when this increases, this decreases, means this length increases, this resistance also increases. And when this area increases, this length, okay, so this, when this area increases, this resistance, I got little, here when this area, I mean to say, it only acts when air when length increases and area decreases. You don't have to go deeply. So here is the great calculus. So this is the one of the most interesting part of metal wire stringers, where you have to know about its derivation, and how to use this formula in calculation part also. So I'll teach you here to how to do derivation of this metal wire stringers. So here you know that resistance equals to resistivity times length upon area. You have already learned this in AS level. Okay, and what happened, this is the change in resistance, and this is change in length, and this upon A. So what happened here is like so plus delta R equals to rho, sorry, this is not phi, uh, okay. So this is rho L by A gives length, rho length by A. So this L is change in length. Okay, so this is changes, and this also in change in resistance. Okay, changes length, changes resistance, and in second step, so I'm only teaching you how to uh, do derivation of this Metal-Wise-Stringers formula, and after that you'll get here resistance, because this is the actual. So this is the resistance, plus delta upon A. Let me change another pen little bit. So here this and this get cancelled, and the result will be length upon area. So here is the conclusion: the change of resistance is equals to this is constant times change in length. So you can also do like this is constant times length. So it can be also written like this. And then after here I have conclusion. One conclusion, that conclusion is about, that conclusion is very interesting, that uh, that change in change in length of wire is directly proportional to change in resistance to change in resistance. I just write here like R, don't get confused. So the conclusion of this is delta R is directly proportional to delta length. So when the length increases, the resistance, when the change of length increases, the resistance also increases. Okay, this is very simple. So all you have to know is how to use this formula in calculations, or in exam. If you asked to write the change of resistance, then you can use this formula to calculate the change of resistance. Another thing is that here is one simple calculation. The simple calculation is like is this, like we know that change in resistance equals to del rho times area times L. Let's say equation 1. And another one, we know this, this is rho times A. So equation 2, let's say this equation 2. And here what can be done, like so dividing this equation, so dividing equation 1 and 2. So what will be the product? Let's see. So by dividing this equation 1 and 2, we'll get delta R over R times rho delta L over A divided by rho L over A. So from this you'll get R over R equals to, let me increase, equals to rho times L over A times A by rho by L. So this get cancelled, so the outcome is so the final outcome is delta R over R equals to delta L over L. So this is the actual fraction, this is the fractional change in resistance. You can call it as um, fractional change in resistance. Okay, so this is fractional change in resistance. So fractional change in resistance is equal to the strain of wire. So this is the strain of wire, so this is the strain of wire. So this is the actual summary of this metal wire string gauge in of A level physics. So if you want to know all those things also, then you can find it out on YouTube also. But why I just solve this question, because I also get confusion a lot of time that how this formula came out. But after digging this part, I came to the actual concept. So I like to, so I thought that I should share this uh, knowledge to other people. That's why I make this video. So also don't forget to subscribe this channel, and also share this video to your friend also in your schools, or in a class, in a in your classroom, okay, whatever. So okay, so this is the actual concept of metal wire stringers.